This conference will now be recorded.
Very good evening, students.
This conference will now be recorded.
Good evening, students. We have been discussing the previous year's questions from JEE Mains papers. So I have got few questions from the paper 2020, which happened 4th September in the shift 2. So let us start our discussions. So this problem says, consider two uniform discs of same thickness and different radii. R1 is equal to R and R2 is equal to alpha R, made of the same material. Material is same, so row density will be the same. Thickness is also same, so we can take them as of having almost same mass. If the ratio of their moment of inertia, okay, so mass, if we don't take also same, that is, yeah, little bit confused statement. Anyway, at least we know the density is same, thickness is same, and but radii are different. Okay, obviously mass will be different. If the ratio of their moments of inertia I1 and I2 respectively about their axis is given as I1 is to I2 is equal to 1 is to 16, then the value of alpha is, we have to find out value of alpha. So look, for a disk, you know, for a disk, moment of inertia about their axis. Their axis means axis which is passing through the center of mass of the disk and perpendicular to the plane of the disk. Okay, that is the own axis. Okay, so moment of inertia we know for a disk mr square by 2 about that particular axis which is passing through the center of mass and perpendicular to the plane of the disk. So this is moment of inertia. Now I have to take the ratio. Okay, so let me write I1 by I2, that is M1 R1 square by 2. Okay, and this is M2 R2 square divided by 2 again. So these two will cancel each other. So let us keep this M1 by M2 like this and get this R1 square by R2 square. So R1 is R and this is alpha square R square. So this R square, this R square cancel each other. So what we get is M1 by M2 whole into 1 by alpha square. Okay, now we don't know what is M1 and M2 for a disk. What will be the, so what will be the mass? Mass is actually, so for a disk it will be same thickness, it is said, so rho into V. Okay, rho is same for both the material. So M1, let us write rho into V1. So V1 will be, say, pi r square into the thickness, let us say something d. So M2 also will be rho pi alpha square r square into d. Okay, So if I just take the ratio of m1 by m2, what we are getting, see, we'll get here further, see, this will be r square pi square. See, this will cancel each other. I'll just get alpha square only. Okay, 1 over alpha square. So here, if I multiply 1 over alpha square m1 by m2, okay, and this is again 1 by alpha square. So we are getting actually 1 by alpha to the power 4. Okay, 1 by alpha to the power 4. So this ratio is given in the problem as 1 over 16, right? This ratio is given as 1 over 16. Okay, I2 as 1 over 16. Okay, and this is equal to 1 over alpha square as well. Okay, so from this ratio I can say, sorry, alpha to the power 4. So alpha to the power 4 is equal to 16, right? So this means the alpha to the power 4 is equal to 16. So again, we know 2 to the power 4 is equal to 16. So from here actually we'll be able to get alpha is equal to 2. Okay, so this is the answer. Alpha is equal to 2. So option B will be the correct answer for this question. So see, this is where is the clue that the mass you are taking. Okay, whether you are taking the mass for both of them same or not. Okay, so in the beginning itself I made a comment that mass may be the same. No, it is not correct, because their radius, okay, radius for the second one is different than the first one, even though they have the same density, but volume is different. So that's why I have to get this ratio also, m1 by m2. So this is how we have to solve this problem. Okay, let us go to the next page, next problem. So here the question says, for a uniform rectangular sheet shown in the figure, you can see this figure. This rectangular sheet has length 80 centimeter, breadth 60 centimeter. The ratio of moment of inertia about axis perpendicular to the sheet and passing through O, which is center of mass, and O prime, that is corner point, is. So basically you have to find out moment of inertia about the center of mass of the rectangular sheet, and you have to find out moment of inertia about an axis which is passing through the corner but perpendicular to the plane of the rectangular sheet. Kind of this, you look this. So if I say this is the corner, so you know this, you will get an axis here, another axis is here. Okay, both are parallel axis. Okay, so I have to actually get the ratio of center moment of inertia about the axis passing through this center of mass and perpendicular to the plane of this rectangle, and about this axis which is passing through the corner. So here, better to remember the formulae for finding out the moment of inertia for each symmetry or each symmetrical object. So in this kind of cases, you know, this is a sheet, right? So you can find out the moment of inertia about x-axis and y-axis. That you'll be able to find out, doesn't matter. But better to remember the formula that moment of inertia about this rectangular, like about an axis passing through the center of mass of this rectangular sheet, is obtained as m by 12 into A square plus B square. A square means length square, okay, plus B square. B is breadth square. Okay, so this will be the moment of inertia about an axis which is passing through the center of this rectangular lamina or sheet. Okay, so this we can find out. See, now you have to find out this distance to find out the moment of inertia about an axis which is passing through the corner and which is perpendicular to the plane of the paper, also plane of the rectangular sheet. So here, you know what you have to do. You have to apply parallel axis theorem. Okay, parallel axis theorem. So how do you write parallel axis theorem? See, for this I can write the moment of inertia about the center of mass plus the mass m and r square. R square is the this one. Okay, so r is this distance. Okay, r square, this distance we have to find out. Okay, m r square. So this, you know, from the formula, say I need to find out this length of this corner. Okay, so from origin to this, if I say this is origin to this O prime, how do you get that? So you can get easily by applying Pythagoras theorem. Okay, so this square, okay, so r square is equal to 60 square plus 80 square. Okay, so this will be, okay, so this will be 100, along with that another 2. Okay, so if I take square root, or r square I have got already, so why to go for something else? But I have to find out this total distance is r square. Okay, I have to find out r by 2 square. Okay, so that's why I need to find out what is r at least. So r will be actually from here, r will be 10 to the power 2, because we have 10 to the power 4, so square root of that is 10 to the power 2, that means 100. So I have got the length of this corner. Okay, corner, then take half of it, that is 50. So here I have to write I0 plus this m into 50 square. Okay, these are all in centimeter unit, but anyway I am going to take ratio, that will not make much differences. So let us take the ratio IO by IO prime. This is m by 12, 80 square plus this is the square, and this is actually addition to this. Okay, so m by 12 plus m into 50 square. So these are the thing. Now we have to do a little bit of simplification to get the final answer. Okay, look, this numerator Okay, let me go to the next page. See here, actually otherwise I can just remove. So this will be actually, see, this is 64 along with like this, and this is 36 along with two zeros. Okay, so this will give you actually 10,000. That means 10 to the power 4, 10 to the power 4. So let me write it here itself, 10 to the power 4. Okay, so this m by 12, m by 12, I can take common and then strike them out, and here I have to actually multiply 12 and this I'll remove. Okay, then what we get, 10 to the power 4 divided by, this will be 10 to the power 4 plus 50 square, that means 2500 along with that 12, so it will give you, this will be 300, this one, and this another 2. Okay, so it will be actually 3 into 10 to the power 4. Here it will be 3 into 10 to the power 4. So it will give you, look, this you have already got the point here. You look, I have got I by I O prime to be 10 to the power 4 divided by 1 plus 3 into 10 to the power 4. So this 10 to the power 4, 10 to the power 4 cancels each other. Then I get 1 by 4. Okay, so this is the answer. So guys, you have to remember this formula for a rectangular sheet, Mount Panacea, about an axis which is passing through the center of mass and perpendicular to the plane of the paper. You have to find out Mount Panacea. You need to actually remember this formula. Okay, this is in this case A, this is B. All right. So this is how you have to solve the problem. You look, there is an option that is C. Okay. Now go to that next problem. A cubic material, a cube metal is subjected to a, a hydrostatic pressure of 4 gigapascal. The percentage change in the length of the side of the cube is close to how much? Where B, that is the bulk modulus, is given. You know, bulk modulus is actually 1 over compressibility. Compressibility. Compressibility means 1 over V by dV. Sorry, let me write. Compressibility is 1 over V dV or delta V by delta P. So now you look, this is actually becoming V. Okay, let me write V by dV down. This is dP by dV by V. Okay, so this is my bulk modulus, and see, it is delta P is given. Okay, but I have to find out, delta P is given, B is given. I have to find out what is the percentage change in the length. So first of all, let me find out what is percentage change in the volume. Delta P is 4 and B is 8 into 10 to the power 10 to the power 10 Pascal. Okay, So this will be 2. So 0.5 into 10 to the power 10. You get kind of this. Now I know, so this thing, this length delta L by L, okay, delta L by L is the one which we have to find out. So since we know V is equal to L cube, now take derivative for percentages. Del V by V is equal to 3 into del L by L. So del L by L into 100 will be the answer. Okay, so this is actually del V by, so del V by V we have found out, right? We'll just put that value. Okay, so delta L by L along with that 100 we have to multiply to get the percentage. Hundred for percentage. Okay, so 1/3 delta V by V. One third. I don't think 1/3. Yes, 1/3 of that. Yes. I'm sorry. This is actually okay. I don't know. This delta V by V 1/3 into 100. This will give you percentage. Okay. So we know this. We have found out 10 to the power 10. This is 10 to the power minus 3. See, the gigapascal I have written wrong. So mega is 6. Giga will be actually 9. Okay, 10 to the power 9. So here, okay, let me write there itself. See, delta V by V, this is 10 to the power minus 10 actually, and here 110 9 10 to the power 9 will be multiplied so that you get in Pascal this one. So this will be 10 to the power minus, I see, I think I have to just redo the calculation. Let me just do it once again. So we know B is equal to delta P by delta V by V. Okay, so what we have to find out? Delta L by L. So delta V by V, let us take here delta V by V. So delta P by B. Okay, now I have to find out, see, delta L by L into 3, that will be volume, delta P by B. So delta L by L is equal to 1/3 of delta P by B. One-third delta P is given as 6 gigapascal 10 to the power 9 Pascal, and this has been given as 8 into 10 to the power 10, and here I have to multiply 100. Okay, so look then what I get. So this cancels, so I get 40 by 24. So 4, 10, 4, 6, again it will be 5 by 3. So this is the thing. So 5 by 3, 5 by 3. So 1.67, option C will be the correct answer for this question. Okay, we'll go to the next problem. This problem says a particle of charge Q and mass m is subjected to an electric field E is equal to E0 whole into 1 minus a x square. So a particle is subjected to E0 1 minus x square. This much force. The particle has mass m, charge q. So this electric field is in the x direction that we can see. So the force, electric force on this charged particle will be along x-axis. Since there is a force, there will be acceleration. Obviously, we'll try to find out the acceleration along x-axis. Then we'll try to find out the velocity at any point x. So what is the force here acting on that particle? That is Q into E naught okay. Now I can accelerate this one as V dV dx. Okay, now we have to find out the velocity. Okay, velocity we have to find out. So let us find out what is the expression for the velocity. Actually there will be am here, so acceleration will be okay. So here we have to integrate it. Q 0 by m So if we do this integration, see on the other hand side 1 minus x squared dx. Okay, so this is the force. Here you look, this is v square by 2. V square by 2 is equal to this one. Okay. So v is, see, general expression. General expression what we get for velocity is so q v0 by m and 2 will be multiplied. Sorry, this is okay. I think I am lost somewhere here. Okay, let me write it properly. Sorry. Yeah, so don't I have space? No, I don't have space here. Let me write this part clearly. What is v we have got? Okay, so first of all, we have got v square by 2 is equal to q is 0 by m. Okay, q is 0 by m. This is the acceleration, and then we had integration x minus ax cube by. Okay, so this is what we have got now. See, if my final velocity is 0, this let us make 0, v velocity 0, then we get what? We get x, then x common 1 minus a x cube by 3 is equal to 0. So see, x is equal to 0 means it is at origin or from the starting point. The velocity is 0 once, and the second choice is this one, when the velocity will be 0 for the particle, and that position we have to find out. See, 1 minus alpha, so this is actually this is equal to 0. That means 3 by a is equal to x square. See, this will be x square. Okay, x square. So what is x? X is square root of 3 square root of 3 by a. So the option D will be the correct answer for this question. We'll just now check or try to analyze thermodynamic processes and corresponding work done in those processes. There is a numerical problem related to that. Let us try to understand. So look this. This question says match thermodynamic processes taking place in a system with correct conditions. In table 1, delta Q is the heat supplied, delta W is work done, and W is change in internal energy. Delta U is equal to. Okay, I hope these terms you have understood: delta Q, delta W, delta U. So here the processes are given as adiabatic, isothermal, isochoric, isobaric, etc. And there are five, 1, 2, 3, 4, 5. 5 options are given again corresponding to each uh, processes mentioned in the left hand side column. Okay, so we have to match them. See, work done will be 0 for which state? See the W, see W work done 0. So this is possible only when this is 0, and this is possible only when this is isochoric process. In isochoric process, the work done will be 0. Okay. Now first option, let us say this. In adiabatic process, you know what happens? In adiabatic process, temperature changes actually. Temperature does not remain constant. So internal energy, see, internal energy also becomes not equal to 0. Okay, in adiabatic process. Obviously, this delta W is also not equal to 0 because there will be some work done. But delta Q is not equal to 0. That means what, you know, there could be change in the heat change. Okay, there will be heat change or heat exchange, we say. Okay, there should be heat exchange, but in adiabatic process heat exchange does not occur. Okay, so does not occur for adiabatic process. So heat exchange will occur for isothermal process. So in isothermal process, see, there is no change in the internal energy. So in isothermal process there is no change in the internal energy. Isothermal process, there is no change in the internal energy, no change in the temperature. That means no change in the internal energy. So this I can actually, isothermal can be going to this. Okay, isothermal process. Isochoric process work done is 0. Isothermal process, see, isobaric and adiabatic is remaining. See, in case of adiabatic process, delta Q is not equal to 0. Not equal to 0 because there will be heat exchange. I'm sorry, not equal to 0, there will be no heat exchange. I'm sorry, this is not for this. Okay, so another point, delta Q is 0, that means there is no heat exchange happening. Okay, in case of adiabatic process, there will be no heat exchange actually. So delta Q will be 0. Temperature change may happen, but there will be no exchange of heat, okay, from the surrounding. So then we don't have to do the other things. So this is isobaric process. So this will be isobaric process. In isobaric process, delta Q not equal to 0, delta U not equal to 0, delta W is also not equal to 0. Okay, let me then see the options which matches with me. So adiabatic process goes to B. Okay, then isothermal goes to delta U. So isothermal second process goes to D. Then isochoric process work done 0. So in the isochoric process, work done will be 0. So then what is matching with what? Let us see. This 3, option 3 is matching with 1. Then I have adiabatic, isothermal, isochoric, and isobaric process. Isobaric process. In isobaric process, all other things will happen like this. Say delta U not equal to 0, delta W not equal to 0, and delta Q is also not equal to 0. So this is actually isobaric process. So this is actually, sorry, this fourth option is matching with C. So let us say 1 goes to 2, 2 goes to D, sorry, look this, 1 goes to 2, 2 goes to D, 3 goes to 3, that is isochoric, that goes to, okay, this is actually A, option A, and 4 goes to C. Okay, so option 2 will be the correct answer for this question. I think we will have the last quick question for today. So this is the last question for today's session. See, a capacitor C is fully charged with V0. After disconnecting the voltage source, it is connected in parallel with another uncharged capacitor of capacitance C by 2. The energy loss in the process after the charge is distributed between the two capacitors. Okay, so here you know what is the procedure to find out that. First of all, say a capacitor, it is fully charged to V0. Okay, so what is the energy? Say here you have to find out loss in energy. So this will be storing energy. If I say C is the capacitance, half C V naught square, this much energy will be stored. Okay, now if I connect this, disconnect from battery and connect this in parallel with another, this is C, this is C by 2. Then what happens? The charges will be redistributed and they will have a common potential. common potential, if I say V prime, then we can find out the charges, corresponding charges. If the common potential is taken to be V prime, then look, Q1 charge stored here, let us say Q2. So V prime, so I need to find out what is Q1, that is V prime by C1. I'm sorry, this will be just opposite way. V is equal to, so Q is equal to CV. Okay, so you have to find out the common potential for both of them. So this can be done in this way. Look, I know the total charge Q1 plus Q2 to be CV0. Okay, and this is charge is CV, right? So C1 V prime, let us write V prime plus C2 okay. So from here we have to find out what is common potential V prime. V prime is found to be, sorry, we have to find out, yes, common potential. So CV0 by C1 plus C2. Okay. Then once we get this common potential, we'll be able to find out the capacitance in parallel, and then you can find out what is the energy stored. So this is one way. The another way to find out this is direct put in formula. See, you have a formula for this loss in kinetic energy, sorry, wait, stored potential energy in case of capacitors. Okay, what is that formula? So that formula is, see, loss in energy will be delta E is equal to half C1 C2 divided by C1 plus C2 into V square. Okay, so let me see the options first. Okay, so look the options here. C1 C2, we know C1 is C and C2 is C by 2. So C1 into C2, so 1 over 2. C1 C2 is 1 over 2. So this is 1 over 4. And C1 plus C2 is actually, to see, so 3 by 2, actually it is 3 by 2. So let us write this 3 by 2. So 2 will go this 3. Okay, I don't know, somehow I think C1 C2 by C1 plus C2 V square. Okay, let me check once again. Okay, we have to find out, I think this is v prime, not this c squared half c v square. Okay, let me just check once again. The question is, the capacitor is fully charged with V0 potential and then disconnected. Okay, what is the loss in potential energy? So we'll be able to use the formula directly, or otherwise we can do it step by step. I think I have written the same formula, like correct formula only. Let me just do this calculation once again. So delta E or delta U, whatever you write, let me write is delta U itself, half into C1 C2 divided by C1 plus C2 into V square, V naught square. So C1 C2 is C into C by 2. This is actually C square by 2. And C1 plus C2, that is C plus C by 2, that is 3 by 2 into C. Okay, so if we multiply here, delta U is equal to half multiplication is C square by 2, then in the denominator it is 3 by 2, 3 by 2, so 2 will be here. There will be C here, this C will cancel one C here, and this will be V naught square. So what you get, let us see this. So it will be actually 1 over 6 C V0. Okay, I think this is the answer for this question. Yeah, so the first option will be, sorry, last option will be the correct answer for this question. Okay, so so we can do this from here also. You look, we can get formula from here also. Okay, you can write half cv square, half cv prime square, and then take the difference of those two. Okay, all right. So with this, I'll stop it here for today. Next day we'll continue with this. Thank you.